Oh, Kendall. That was interesting. I just remember when I was a little kid, we had these horrific plastic masks that were the worst things. You take them off and you have all these deep lines on your face and you're like, forget about it.
Like smell. The rubber ones.
Oh, it's terrible, man. Huh?
Like the rubber ones that suffocate.
They were pure plastic and they were hard as shit. Your mom would tie it on you. That's too tight. Shut up, you want candy? Yes. Oh man, I should record that for YouTube. Jeff tells his fabulous childhood stories.
You know where Halloween came from?
Walmart, no. Huh? It was All Saints Day. Yeah, it was the eve of All Saints Day. And like, wasn't it good little people would go to? It was basically like any holiday, basically a perversion of.
But before that, it was Samhain.
Who's who?
Samhain.
Samhain? Oh,
Samhain.
yes.
Pronounced Samhain, right?
Yes. Just like keep Saturnalia in Christmas. Keep Saturn in Saturnalia. There you go.
And they used to carve turnips instead of pumpkins. He's sick of me already. We're gonna start that.
Yeah, I know. It's like, all right, Aubrey, great. Mm. Oh, there we go. Oh. Melissa came here. Hey, Sierra. Welcome. Oh, it's Braden back there. It's like, what little person is in the back? So I thought we would start with, well, first off, actually, any questions? Because, of course, we got that fantastic quiz tomorrow. Alasia!
Oh, hey, guys.
I like that answer.
It's okay, at least it's a consensus, you know, like, general consensus.
I'm thinking about trig.
Unit circle for Halloween.
I'm going to dress up like all of my students at once. So basically, I'm going to be,
Really?
the hell's this guy talking? Okay. Any questions from specifically 6667 homework or any of it?
The system was going to be something similar to that? Word problems and rock properties?
It's going to be exactly that. Because the quiz tomorrow is on
Those
6 and 6-7. Yeah. It's going to be, okay. So, remember 6-6 is about solving trig equations, yes?
Yeah.
Right? So, if you don't have a specific homework question, you could right now say, hey, Jeff, can we do like an example, solve an equation? Yes? Say it. Sorry. Sorry. That was kind of mean. Say it. Now I can turn to Sam Kinison. Say it. That's a reference to probably what everybody said. I'm sorry. Old man making references. Stand back. So one level of this would be. All right. Let's kind of level up. Here's one possible thing I could do. Yes? Yeah, so everything's based on 3. This is already 3, thank you. How do I make this into a 3? 3 to the. So one thing we can do is, what's 81? Isn't 81 9 times 9? And each 9 is 2 3s. So how many total 3s in 81? 4. How do I simplify this? All right. So have we managed to get the bases the same? So all that needs to happen for this equation to be true is what? Yes, the exponents have to be equal. We got the bases the same. Now we just have to make the exponents the same. And that's why we're allowed to make this become this. Because if the bases are the same, then the original equation must be true. If this is true. So how do I solve this? This is beautiful, right? This is a beautiful little linear equation. What's the only thing in the wrong place? Yes. Okay. And then, of course, to check it if you have time, you could do 3 to the negative 4. You could do 81 to the negative 1 and see that they're the same. How you guys doing? What is 3 to the negative 4? Good, because 3 to the 4th is 81. Negative makes it flip. What is 81 to the negative 1?
1D? No. Yes.
Just flip 81, yes? I like it. Okay. Is that okay? So if I give you an exponential equation, an equation's got exponential parts to it, can you make the bases the same? If the answer to that is yes, then you do, and then you make the exponents equal to each other. Yes? You take it from a gross-ass equation to a, ooh, look at that. Okay, maybe? That's the technical name of this. This is the, ooh, look at that. Okay. So, of course, the level up from that is, what if I do this instead? Then you cross it out and hope I forgot I put it on there.
You gotta take the L and N over there?
Yes. Take the L, N. So, why would I do that, Aubrey?
Because it allows you to bring the exponent.
Yeah, it's the one function we've seen so far that allows you. Okay. Sorry, I got my phone is plugged into life support here, so I can't do too much. My variable is stuck in the exponent. Whenever you solve an equations, you're basically trying to free your variable up so it's able to move around. The only thing we know of that will bring a power down is logs. Now, students get lost in this sauce here because there's a lot of shit going on. The first thing is I've already made a mistake. Yeah, this whole thing has to multiply by that. Okay, let me stop for a minute. You guys, is that cool, the first couple steps? What told me I had to use a log? Yeah, good. All right, so two things. I can't make the bases the same. Right? Not easily, anyway. I'm sure that 3 to some power is 17. I don't know what the power is, so screw that. Does that make sense? Secondly, it's because my variable is set in the exponent, and the log is the only thing that could bring it out of it. Yes? Let me focus on this point for a second. How do you solve this equation? Yes, why?
To get it up.
Yes, my variable is stuck in the denominator, so I do the thing that will make it unstuck. Right? As gross as that looks, I can multiply the 3 of blah, blah, blah. I don't care. What about, how do I solve this equation? We've done this a million times, but still. Huh? Cube both sides, because that's the thing that will free my x, so it's able to equal something. I can move it around if I need to. You guys kind of with me? So that's the log is the only thing that will help my x get the hell down from where it's stuck. Okay. Now what do I do? I could, but that would. All right, you could.
But not your best option.
I don't know. To be honest, I probably would. But it might look weird for students in general, I think. So, Aubrey, you totally could. Maybe I'll do this both ways. So, if you take this and you distribute it. And again, what's wrong here? Is my x stuck somewhere? Yes, stuck inside. So, if I distribute that, I free it. So a lot of the steps you take in an equation is trying to make your x free. Which is a really strange phrase, but we'll be okay. You gotta let your x out of your garage. Oh, sure. Hey, Davey. So let's see, you bring that natural log through. Okay. And then, now do you see what to do?
Yeah.
We've done this kind of thing before. Our variable seems to be in two places. Do I have all my x terms together? Or all my x terms together? What's the one term's in the wrong place? Yes, x ln 17. If I move that here, then all my x stuff is together and all my non-x stuff is together. Yes? So if I move this over, and of course this, I've already gone through this with you. I said, how many x's do you see? And people say 2, and I say, no, there's 1. Right, I have my little moment. Why is there only 1 x? Because I can, yes, good. GCF that dude, take it out. And last step, get x by itself. Divide by the crap you don't want. Bye. So bookkeeping becomes a problem with this kind of problem. Yes.
Why wouldn't I just combine 2x ln 17 minus x ln, I mean 2x ln 3 minus,
Combine these. How?
wouldn't it just
You can only combine what kind of things? Like terms. I have 2 x ln 3s and 1 x ln 17.
But can I take an ln 3 from the ln 17 and maybe ln 14?
Of course not. Is the square root of 9 minus the square root of 4 equal to the square root of 5?
No.
No, you can't subtract the insides of functions.
Okay.
Because it's not ln times 3, in which case you're like factoring an ln out. It's ln of 3. Same thing as square root of 9. Right? Does that make sense? So you can't subtract the insides of stuff that's inside of functions. Yeah. Okay.
Let's have a question.
Yo.
So from the start, if we took the natural log like ln of both sides, why like not log base 3 so we can cancel 3 with it?
Oh, I do ln, not just because there's one less letter, but because ln is one of the log functions that I can see on the face of my calculator. Because if I wanted an approximate answer, you'd have to plug this in your calculator.
Yeah.
Yeah? So what 2 logs can I see on the face of my calculator? ln and log, which is log base 10, right?
Yeah.
So you guys understand Anas has got a really good question. He's like, Jeff, what the hell's wrong with you, man? Well, he didn't say that, but I heard it. No. And he says, why didn't you, Jeff, man, you're so weird. Why didn't you just take log base 3? That would just kill this dude.
Yeah, will be 2x.
Because there's no log base 3 in my calculator that I can see. Do you see what I mean?
Yeah.
Because what I'm going to ask on the test or quiz, I'm going to ask you, can you please tell me the exact answer and an approximate answer? So you have to plug this into your calculator. Yes?
Would you not want to like simplify the bottom to ln 9 instead of 2 ln 3?
Oh,
Or does it matter?
no. And to be honest, it's the word simplify normally means carry out the operations, and that's just a rewriting of the form of it, so it doesn't really affect anything. If you did, I wouldn't take points off. They're like, oh. Is that all right? Is that okay?
Use it when I say the S word.
What's the S word?
Simplify.
Oh, simplify? Simplify.
It's extra work.
It's even worse if you sing it. All right. Extra work. Okay. Yes, sir.
Your extra work.
Can we go over 6.6 question 13?
Ah. You asked that as if I had prepped things.
Oh, the one I asked this morning.
Oh, it's the one I asked you about too. Earlier, earlier last week.
Oh, I was gonna say, I don't think I saw you earlier.
I have it right here if you want it.
I was really worried about my mental health for a minute. That's what I asked you earlier. I just saw you now for the first time today. What day is it, kids? What year is it? All right. All right, hold on, I'm sorry. Section who to what?
6.6.
Yeah. What is that? Oh my God, Mila. 6.6 number? 32. There, this one?
13.
Oh my God, 13. Sorry. So many pop-ups everywhere. Oh, this one. Okay. Everybody see that? Was it minus 10 equals? You already forgot, Jeff. Good Lord. Negative 42. Okay. Come back. Real quick. If I had this, 3 to the x equals negative 1. What's the answer?
One.
3 to the first is 3.
There's no real.
3 to the negative 1 is 1/3. 3 to the negative billion is 1 over 3 to the billionth power. Where is there an asymptote for 3 to the x?
0.
0. Can you get a negative output then? No. So a to the x can't have a negative output. You can't take a number that is positive, raise it to a power, and make it negative. You guys with me? Does that make sense to myself? That's what leads to the idea of the asymptote being there. Yes? So I can't stress this enough. You're going to have a so much easier time with almost everything the more you know the shapes of the functions. I've already discussed with you how, like, log domain questions, if you remember the shape of it, you're like, oh yeah, there's an asymptote. Oh yeah, it's above 0. Okay. Then you can kind of work based off of that. So the more you know the shapes of things, the easier a lot of problems are going to be. So if you look at this, what's the main difference between these two equations? What's this guy got extra that this guy don't have?
-10.
Yes, so I got to add 10 first. Now right here, you don't have to do any more work. If you do try to do more work, you'll still get the right answer, because what would you do to kill the E? Because you got to get the R free, yes? So now we can do what Linus. Natural log of Linus. That's what just happened in my head. I just took a natural log of one of my students. I'm sorry. This is really not a good idea. Do you guys, is anything wrong with this side? A lot.
You plug it into your calculator.
It'll freak out. Yeah. It'll grow little arms and go, danger. So you didn't have to, right when you got e to the r plus 10 equals negative 32, you could stop and you could just say, can't be negative, no solution. Do you guys understand? Yes, sir.
Maybe just to help me understand that, why can't there be any negatives?
The output can't be negative because, take 3. 3 squared, 3 cubed, 3 to the 4th power, that just gets bigger positive, correct? So that's definitely not becoming negative. So if I go the other way, 3 to the 1st, 3 to the 0, 3 to the negative 1, 3 to the negative 2, these are always 1 over 3, 1 over 3 squared, right? So it's always 1 over shit. You can't even get 0 to come out, let alone get into the negatives. So if I have a function that's continuous, that's not an idea we talked about, but it basically means what you think it might mean. It doesn't like teleport somewhere, it doesn't do anything weird like a piecewise function. Where's it going? But if I have a function that's continuous, it can't suddenly teleport from one side to the other. So if it can't even be 0, it's got no way to become negative. It can't even cross the x-axis. I guess you're with me, okay? All right, so I'm very bored. Is that okay? So like if I write this equation, can anyone see why I have no work to do? Why do I have no work to do? Why do I know the answer? I know the answer. Why? Can anyone see? Can you add 1 to a number and get the same thing when you add 2 to it? That's what that says, yes? So I know there's no solution. I can't do that. Do you see what I mean? So if I have 5 to the x minus 7 equals negative 11, no solution. You can't raise 5 to a number and make it negative. Okay, maybe. The most you could do is make it bigger or make it 1 over something. That is all you can do by raising a positive number to a power. That's all you can do. Okay.
What happens if you raise a negative number to a power?
Oh, that gets tricky. Because if your base is negative, if you raise it to an odd power, it stays negative. If you raise it to an even power, it becomes positive. What happens if you raise it to, and we're not going to focus on this, dear God. What happens if you raise it to an irrational number? Is that odd or even? I don't know. So screw that. We're not going to look at negative bases.
What if you raise it to a negative number?
A negative base to a negative number.
Yeah.
Yeah, so the answer could be negative or positive. It actually would go, it would be really exceptionally weird. Listen, we're not going to talk about this a lot, but you guys understand, if I just stick with whole number powers, that answer is negative, that answer is positive, yes? So if I want to graph this, the output for 1 is negative 2, the output for 2 is 4, the output for 3 is negative 8, the output for 4 is 16. Do you see what I'm saying? So the graph of this is trippy as shit. But then you start to realize all the numbers between 1, 2, 3, 4, some of them are effectively odd and some of them are effectively even. So it's like bouncing back and forth infinitely fast. That is as much as I'm going to say. I'm sorry. But it's not a bad question. It's a beautiful question. Of course you should ask that question because I keep saying positive base. So if nobody asks me that question, I get a little concerned. But that's as much as I'm going to say. Can you guys see that? It gets freaky as shit. So we don't talk about it too much.
And that's different than just 2 to the power without the parentheses.
Yeah.
Totally. Yeah, what's negative 2 to the first? What's negative 2 squared? Good. Because it's 2 squared with a negative on it. Yes? So the more you see the difference between these two, the more you understand PEMDAS. That is 4. That says put a negative on it. What do I have 2 of here?
Negative.
2 negative 2s. Negative times negative is positive. Cool. So I had a student come up. This happens every semester almost. They'll come up, they'll write this in the calculator, and they'll say, Jeff, I think my calculator's broken. It's telling me the answer is negative 4. I'm like, it's right, dude. Think about it.
We've been making calculators a lot longer than we've been thinking about math.
I found something they never thought to look for. Okay. Just like vaccine deniers. I love it. Okay. Anything else before I keep going? So what about if I have logarithmic equations? I don't think we talked about that. I mean, we can start with this one. Yes? How do I solve this?
Raise both sides to 7.
Put it in the...
Oh.
Yes? Put it in the wash machine. So then I get...
Wash it clean if it sins.
I like it. Don't put your logs in the dryer, though. It gets really loud.
Oh, the homework had problems about P of t equals P of 0 ERT.
Sure. What'd you have to do with it? I think most of the time you just had to plug stuff in. Yes?
And finding R as well.
Okay. So then it's solving equations, right? Okay. If they give you P equals P naught E to the RT, yes? Pretty. Then If they tell you you start with 10,000, after 10 minutes you have, what do you got, Jeff? So start with 10,000. After 10 minutes you have 5,000. Well, you plug 5,000 in there. Your initial amount plugs in there. Your time plugs in there, and then you solve for it. So you have to divide, take a natural log. Does that make sense? So then it's an application. So all word problems are applications of solving equations, because you are setting up the equation you have to then solve. That's why word problems suck. The hardest part about them is setting up the equations. Okay, maybe. Okay, you guys are doing great. You guys are holding on. All right, I'll tell you this. If there's no further specific questions, I'm going to jump right into a review of some stuff we did last time. Okay, so can somebody remind me arc length formula? There's a theta in there. There's an r in there. There's an r theta. S, cool. We got it. Takes a village. Can anyone remember there's a certain requirement to be able to use this function? This formula, huh?
Theta has to be in radians.
Theta has to be in radians. And on one level, it's not even something to memorize. Radian is the number of radiuses, yes? I'm just going to say it like that instead of reading it. Radians are the number of radiuses. So if theta is 7, how many radiuses is that? 7. If theta is 7, not 7 degrees. So if I don't say degrees, it must be radians. So if theta is 7, I have 7 radians. And every radian is 4 inches big. How far did I go? I have 7 of them. 7 radiuses, and each radius is 4 big. How far did I go? 27 times 4. So, you with me? Does that make physical sense? If theta tells me, if it's in radians, it tells me the number of radiuses I've walked. So if it's 7, I've walked 7 radiuses worth. If every radius is 4 inches long, it's 7 times 4. It's theta times r. Degrees are bullshit. Degrees don't mean anything physical. They're just like, let's cut it into 360 pieces. You know, oh my God, this is thin as freaking pizza slice. It's a little, I don't know. All right. So, what's wrong with this problem then to be able to use that formula? What the hell? Jeez. So how do I convert this to radians? Yeah, say it again. Yes, put the 180 degrees on the bottom so the degrees die. Die. And then pi on the top. Pi on the top. Reduce. Reduce. Pi over 3. So then what would I plug into this? Do they tell us? What do they tell us? Oh, radius of, I just gave it away. So the radius is 8. So I plug 8 here. And then just throw all that in the old calculator. Calculator. What's that going to be about? 1.05. I think it's going to be about 8.39. What'd you get, Kendall? Damn it! I'll retire. I'll retire. I'm sorry. What is it? 838? All right. That's good enough for government work. Okay.
837.
Here, approximately. Okay, get up there. So S equals R theta, and guess what? You're going to enjoy this so much you have to memorize this. All right, so you have to know this. The more you know this, the more ahead of the game you're going to be when you take calculus, because it's going to show up in calculus. Who remembers this one? Yeah, 1/2 r squared theta. This one I might let you get away without knowing. We'll see. No, I better make it official. Yeah, I won't make you memorize this one. This one comes up often enough you should know it. This one's okay if you have to look it up. So again, we have the same problem here, right? Now real quick, if 60 is pi over 3, what's 30? Yeah, what's half of pi over 3? All right, let's do it this way. 30 degrees times pi rads, 180 degrees. Reduce.
Oh, you suck.
And then you just plug and chug, right? Radius is 5. And, oh, I forgot my units. I suck. And the angle is pi over 6. What's that, Jeff? I don't know. 12 is going to be 6 and 1/4, so it's going to be, I can't remember which way I went. So it's like 6.25, but it's going to be which direction, Jeff?
6.54.
Well, that's pretty close. That's,
Yeah.
All right. I feel better. Okay, 6.54 watts. Inches who? Good. Area, squared units. Okay, kick ass. Okay. So tonight, what I want to do is I want to review the last thing we did last time, which was we constructed an equilateral triangle. I'm going to very quickly remind us what we did. Is equilateral, so it's the same size on every side. I dared to try to make it represent I just drew every equilateral triangle that has ever and will ever exist.
That's crazy.
I know, and it took me that long. We focused on the right triangle here. What's this angle here? 30, because I cut that 60 in half when I chopped it. If I draw that right triangle over here, how long is this side? I like it. And then if you use good old Pythagorean theorem, Jesus, Jeff. X squared is 8. Stay with me now. You guys with me? I'm doing this a little fast because we did this before. So h squared equals x squared minus, if you square this, you get 1/4 x squared. A whole x squared minus 1/4 of x squared is 3/4 of an x squared. And if I take a square root, then I'm going to get rad 3 over 2x. Okay, so that's one of the very last things we did last Wednesday. Okay. Now what does this do for us? I don't know. Oh yeah. How big is this equilateral triangle? Yes, we don't know. So it could be billions of miles long, or it could be angstroms long, which is very, very tiny. Huh? Angstroms. It's like 10 to the negative, I forget exactly, 10 to the negative 14? I can't remember. Something 10 to the negative 14 meters, maybe. Angstroms are stupid because they're like wavelengths of light level. That has nothing to do with anything. I'm very sorry. It doesn't depend on the size of the sides. It just depends on the angle. So for example, what must sine of 60 be? No matter what angle, what triangle it lives in, what's the sine of 60? Does somebody remember what the sine is? What's the sine defined to be? So what side over what side?
Y over R.
Yeah, so remember that sine likes y. Sine likes y. That'll
I'll never forget that.
get it. That's not. Sine likes y, cosine likes x. Sine likes y, cosine likes x. The more you know that, the more you can do a ton of shit. You'll see. So sine is going to be h over x, yes? But what was h? Yeah. Root 3 over 2x over x. The x is canceled. The sine of 60 degrees is rad 3 over 2. That is simply true. That does not have to live in a triangle. That is just a true statement. Let's do this. Who has their calculators? Anybody need to borrow a calculator? I want to do this right now. Right now. Who needs a calculator? Anybody?
Unit circle would agree.
Everybody's got one? Everybody's got one. Got one too. Do I have one? I do now. Okay. So first off, do the square root of 3 divided by 2. Put your glasses on, Jeff. Kabam! Okay. So everybody's got that, right? Now do me a major favor. That you're going to become very acquainted with this. Hit the mode button right there, right? And right next to second. Mode. This is huge. Right there. This is huge. Jeff did not live this experience, but if you're not careful and you forget to change this, you could fail a quiz or something. Like, that didn't happen to me at all. I'm not still bitter about it. What do you think for right now? Degrees. Right now it's degrees because I got 60 degrees here, yes? So what I want us to do is to try, what did I just claim sine of 60 is? This. And now we know what that is, yes? So plug in here. Do you guys see sine? Sin is here. Okay, sine of 60. Enter. Yeah, it's crazy. No way. So here's the trick. This is what you got to realize. All the trick stuff is built from ratios of sides of right triangles. But then we realize, I don't care how big or small you make the triangle, the angle stays the same. So then we can sort of take the idea of sine and cosine and all that stuff out of triangles and just they live by themselves. It is now a function. 60 is an input, 0.86 or square root of 3 over 2 is an output. Okay, is it all with? So like, for example, just to let you know where we're headed, after this, in chapter 8, we're going to start the graph, sine and cosine and so forth, because they are their own functions. Okay. Yes?
When I put in sine 60, I got negative.
Do me this favor. Go to mode, and make sure degree is highlighted.
Oh, okay.
Yeah. If you had the wrong thing highlighted, let's see if you got this answer. You got that answer before?
Yeah.
There you go. So you got to tell it degrees. Then you're golden. Okay. Yes, sir.
So no matter h is and x is, it's always going to be.
Yeah, because what just happened? The h we figured out was rad 3 over 2x divided by the hypotenuse, which is x. So the x went away, so it doesn't matter what x is, it's going to cancel. Remember when you guys were up on the board and I made you guys triple and double and whatever the size of the triangle, and you made the same ratios and they all freaking reduced. Of course they did. It's like x is, I made them double it, triple it, right? That's always going to cancel. That's why if I have an input of 60, sine's output will always be rad 3 over 2, forever. Okay. What is cosine of 60 degrees? What is cosine like? And what I mean by that, I really want you guys to understand this. The x side. If the angle is in the base, this is the x side, this is the y side. So cosine is what over what?
X over y.
No.
Is it just 1/2?
Yes, it will be. It's x divided by h, or r, yes. So we'll say x over r. That'll be x over 2 divided by x. Now real quick, what is 3 chairs divided by 3? Like you have 3 people. 3 chairs divided by 3 is 1 chair. What's 3 cans divided by 3? 1 can. So what is 3 halves divided by 3? 1 half. So what's x halves divided by x? 1 half. The x is things. Yeah. So like Damien said, because Damien was like, I'm getting impatient, just stay with the answer is. You're good. That's 1/2. Now I want to point something else. Everybody, I need you don't have to memorize this. You're never going to see this again from me, unless somebody asks me to redo this for some reason. This is a derivation of these values. Now we know those values. You have to memorize these amongst others. And we'll get to those. You guys with me? Yes, sir. What's the x side of the triangle? And what's the hypotenuse of the radius side of the triangle? Yeah. So when we say cosine is x over r or x over h, it's the x side of the triangle. Yes. Let me see. Should I do this right now? Yeah. Let me try this. 60 degrees. Is 60 degrees closer to the y-axis or the x-axis? Yeah, because this is 0, 30, 45, 60, yes? Which function likes the y-axis? What did I say? Sine. So which one should be, I always talk about them like turtles, like the sine turtle comes out of the shell when it gets closer to the y-axis. So here the sine is totally in its shell. I don't like it here at all, yes? And then as it gets closer to the y-axis, it comes out of the shell. So the output to sine should get bigger. And sure enough, at 60 degrees, which one's bigger, sine or cosine? Sine. Cosine hates this shit. It is far away from home. Maybe? To me, that makes the most sense. And that could just be me, but if you remember sine likes y, cosine likes x, a lot of things come together and make more sense. Why is sine bigger sometimes, cosine bigger sometimes? It depends on how close to the x-axis it is. Okay, maybe. Maybe? Maybe. Holy shit. Can we look at 30 degrees now? What's the sine of 30 degrees? What's the y side now if I look at it with 30 in the base? Well, I'm sorry. That's x over 2, yes. And what's the hypotenuse still? X. So some of you guys should not be surprised. Sine of 30 is the same thing as cosine of 60. And then what's cosine of 30? Yeah, you could either build it. It's h over x, which is rad 3 over 2, x over x. The x's cancel, you get rad 3 over 2. But cosine of 30 is the same thing as sine of 60. Okay, let me push my luck here. What do you think the sine of 0 degrees is? Would that represent a triangle? No, so I appreciate the looks of concern from people. Huh? No. Remember, what does sine like? Y or x? Y. Sine loves y. 0 degrees. That's all. Which one? X or y? 0 degrees is all what? X is all X. Are you guys cool? Are you guys understanding what I'm doing when I'm doing this? Yeah. Sometimes I have students come me a week later like, oh, what you're doing your arms? Like, why didn't you ask me in the moment? So this is the x-axis, that's the y-axis. 0 degrees is all X. Does sine like it there? No. Hates it there. So what sine is 0? 0. 0. Kick ass.
And then cosine of 0 is 1.
Cosine of 0 is 1 because cosine does what with x? Loves the shit out of it. This is home. So at 0 degrees, it's totally out of the shell. It's like, oh, sweet. And then if you start to move away, okay, maybe? Maybe? No? Screw you, Jeff? And just to bring it back to a more visual thing, I'm pretty sure I talked about this before, but let me reinforce what I just said. If I'm at 0 degrees, well, let's say, if I'm at 60 degrees, Jeff, you can do it, buddy. Do you see how the y side is big and the x side is smaller? 45 degrees, they're roughly the same size if I knew how to draw a scale. Okay. 0, so do you see how the y side gets smaller, smaller, smaller? Until I smush it all the way down, is there a y side now at all if I'm at 0 degrees? So of course sine of 0 is 0. If sine is the y side divided by hypotenuse, and I go to the point where I'm nothing but hypotenuse, yeah, that's my hypotenuse, yes? Oh, I'm just hypotenuse. Then that's 0 divided by arm is 0. Okay, maybe. So what's sine of 90 degrees? I can do it. Say again. No, 90 is pi over 2 radians. 90 degrees is pi over 2 radians. What is sine of 90? Sine likes y. So the same way that cosine is 1 here, sine is 1 here. Can you stop for a minute? So what are the values we talked about so far? 0 is a possible output. 1/2 is a possible output. Rad 3 over 2 is a possible output. 1 is a possible output. There's one more angle we haven't talked about. Huh? No. One more angle we haven't talked about. Here's what's funny about tangent. Here. You guys can reference your notes. Remind me, what is sine of 30 degrees? By the way, here's how I do this. Guys. Here's how I did this when I was first learning this business. 30 degrees, closer to the x-axis, sine likes y, 30 is further away, sine's going to be smaller, it's going to be 1/2. That's the thought process I go through. I didn't really memorize them as sine 30 is 1/2, let me write it on a flashcard. No, I'm like, sine likes y, 30 is closer to x, sine don't like it, it's the smaller option, it's 1/2. That's what I go through, so I have more room to memorize other shit. So sine 30 is 1/2, what's cosine of 30? Yes, it's the bigger option. It loves the x-axis. 30 is close to the x-axis. It's going to be the bigger option, rad 3 over 2. It's not the biggest option because it ain't in the house yet, but it's in the front yard, so it's happy. So what's tangent of 30 degrees? What's tangent in terms of sine and cosine? Okay, tangent is y over x. Which one goes like y? Which one goes like x? So tangent's also sine over cosine. So how do I figure out tangent of 30 degrees? Good! I mean good. I get so excited. So it'll be 1/2 divided by rad 3 over 2, which is, now here's people, can you guys please do this for me? What do the 2's do? They cancel, right? Don't make a big deal out of this shit. You guys with me? The 2's just cancel. So I got 1 over rad 3. What's wrong with that? So what do you have to do to get the radical not to be in the denominator? Do you guys remember? I'm pretty sure we talked about this. I understand that, but no. Real quick, the bottom sucks because it's a radical. Real quick, why can't I take the square root of 3, but I can take the square root of 16? What does 16 have in it? 2 4s. 3 has 1 3. So how many more 3's does it need for me to be able to do it? 1 more 3, yes? So I'm going to multiply top and bottom by the square root of 3. So I can give it, that's back, help us God. I can give it, and then the bottom is just going to be 3. So it's rad 3 over 3.
I wasn't there in the room.
Hmm?
I was in the room. Ballpark.
Oh, okay.
I thought that answer was
All right, you'll work through it. How we doing so far? You guys okay?
yes, I'm letting
This is huge. You need to understand how important trig is. I have students in my calc class who either never took trig or forgot about it. And they're having to learn basically 2 classes worth of stuff at the same time, which is not fun. So you want to go into calculus knowing as much trig as possible, especially if you're going to go to Calc 2. Does anyone think they're going to Calc 2? I can't remember if I asked this question later.
maybe.
Calc 2, chapter 7, over half of it is trig. Chapter 7 is the first chapter you hit in Calc 2. So the first week, you're going to be starting to get into nothing but trig for a while. So I try to get people to understand, you got to review your trig. Very quick side note, some teachers can teach 180 and barely do any trig, and I think that's so mean. That is the meanest thing you can do for students, because you hit 280, top 2 like a wall. So when I teach 180, I make sure to infuse trig in a lot of places. Yes? So it is possible to teach 180 with very little trig, and that's not good. So I hope whoever you take, you get somebody who's going to teach you have some trig in it. I'm sorry, did somebody have a hand up? I just kept talking, yes.
What did you say were like the possible like outcomes? You said like one half.
Yeah, so what are the outcomes we've seen so far?
Yeah.
So like what's sine of 0 degrees?
0.
0, good. And what's sine of 30? 1/2. What's sine of 60? And what's sine of 90?
1.
So those are the ones we know so far. So if you know, we're not going to memorize all the angles. I have no idea. We're only going to have one more angle we're going to look at.
Yep.
Yep. Just made my note.
I do know.
Is everybody kind of with me? So then that's why the idea of, 30 degrees is close to the x-axis. Sine's going to be small. It's going to be the smallest option out of the ones I'm supposed to know. That's a way to have it up in your head. Yes? If you just want to memorize this shit straight, you can do that too. That would just kill the guy. I don't want to do that. Yeah, okay. If it'll drive you to drink, I don't know. Maybe don't. If it does, then, try some rum chata. Rum chata is good.
I'm on the edge of my seat here. I want to say it.
Huh?
I'm on the edge of my seat here. Like I want to say it.
All right. So let's look at 45 degrees.
I'm on the edge of my seat.
Can you guys draw? Well, here, let's do this together. I want to draw a 90-degree angle where the two legs, meaning the non-hypotenuse sides, are the same length. Right? So you have these two legs are the same length. Pretend like that's good. And then that comes in. Is that worse? Maybe.
It's all right.
So how long is this side? We don't know, but how long is it?
X.
Good. And how long is this side?
X.
That's crazy. So pretend like those are the same length. Maybe my triangle's fallen away from
As
us.
long as the label is.
It's perspective. Yeah. Damien said, just like the SAT says, images might not be to
I was
scale.
about to say yes. As long as it might not be the scope, but as long as.
Can somebody figure out what this side is?
H.
X squared plus X squared.
Okay, so let's call this C for the moment.
So,
Makes sense. So what's old Greek dude say? I don't know, some old Greek shit. No, but what specifically does Pythagoras say? Or his followers? C squared equals?
B squared plus B squared.
Yeah, in this case,
X squared plus X squared.
kick ass. And what's x squared plus x squared? Do not say x to the fourth.
2x squared.
2x squared, thank God.
Holy crap.
so C is the square root of, well, it's X times.
What's the square root of x squared?
X.
What's the square root of 2? I don't know. Oh man, it's time for me to wake up.
Who is getting a phone call?
It's all been a dream, Jeff. What level am I in? I don't know. Now, we could do all the same stuff we did before. By the way, what must this angle be? Does anyone know?
45.
It must be 45 degrees. Since these are the same length, the mouths have to open the same amount. I don't know if this makes any sense, and I'm not going to stop saying this. The sticks are the same length that fit in the mouths. Do you see? The 45-degree angle, isn't that like a mouth? And this is a stick in the mouth. And if the other way, if this mouth is the same size stick, they have to have the same angle opening. The mouth has to be open the same amount.
Wait,
It's a
which
long
part's
way to
the
go
stick?
for that. Huh?
Which part is the stick?
So in this case, for the 45, that's the stick. Inside this 45-degree mouth,
Oh,
yes?
but the other 45.
This stick is the same size, so that must also be 45 degrees.
Ah.
And before I knew it was 45, I knew these had to be the same length. Since that's 90, 180 minus 90, there's 90 left. Cut in half is 45. That was very quick, and I don't seem to care. So can somebody tell me what the sine of 45 degrees is?
Root 2.
Because this is now x root 2. Try again.
What?
Try again.
Was that wrong?
Yeah.
What?
What'd you say? I think you said root 2.
Root 2 over 2.
Oh, over 2. Didn't hear that part. But you got ahead of us a bit.
Oh, sorry.
Let's slow down.
X over X root 2.
Yeah, it's going to be the y side. So I'm looking at 45 here. Over the hypotenuse. What do the x's do? Cancel. This is what I thought you did, Damien. What mistake did I make? If these x's cancel, what's on the top? And then you have to do the same thing we did earlier, correct? So what's the bottom need? One more 2. Poor little dude. Now, if sine loves it here and is 1, and cosine loves it here and is 1, what must be true at the angle right between those two? Cosine and sine should be equal. And that's exactly what we get. If I do the cosine, Jeff, if I do the cosine of 45 degrees, it's x over x squared, 2, blah, 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 rad 2 over 2. Okay. Now let me show you. It's funny, what I'm about to show you is controversial. But is that the controversy is stupid. It's just an interesting thing. I'm not saying this is screwage, I'm just saying. This is just neat. This is just a neat happenstance. Some of you guys might have seen this before. If I go with sine, what sine is 0 degrees again? 0. Kick ass. If you haven't got it memorized yet, I don't blame you. Your sine likes y. 0 is nowhere near the y. 0. They don't like it there at all. What's sine of 30? 1/2. Do you see how it grew just a little bit? And if I draw in my triangles, you can see the y piece growing as you move around the circle. Okay. Do you all agree, real quick, do you all agree the square root of 1 is still 1? So even though it's excessively weird, if I replace that with the square root of 1, is it wrong? No. Do you all agree square root of 0 is still 0? Do you all agree that if I divide that by 2, it's still 0? Okay. What did we just figure out the sine of 45 degrees is? And again, it's a little bit bigger, yes? Do you see the pattern? Rad 0 over 2, rad 1 over 2, rad 2 over 2, so sine is 60, which is what it is, yes? And what does it mean sine 90 should be if I follow the pattern? Rad 4 over 2, what's rad 4? What's 2 divided by 2? Thank you. Okay. That's just an interesting happenstance. There are math people that are angry. Don't show students this. I'm like, just calm the flip down. Because this is just an interesting thing that happened. But I don't know if this will help you. You can see, and you can see sine growing because sine likes y. So the y side just does nothing but get taller, yes? And of course the cosine does all this shit in reverse. It starts here and then it shrinks, 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 shrinks. And of course halfway between is where they should agree with each other. So without doing any work, can somebody tell me very quickly what the cotangent of 45 degrees is? Cotangent of 45 degrees. What's cotangent? It's
x over y.
x over y, so it's cosine over sine. And what's true at 45 degrees? Cosine and sine are the same. So what's cotangent of 45? 1. I like Alasia's in the back, just like. It's just 1, dude. And I'm like, what? Guess, is that cool?
Yes.
So 45-degree angles are awesome for tangent and cotangent. They're just 1 or -1. We'll find out. Okay. Because how many quadrants have we talked about so far? No? How many quadrants have we talked about? 1. Yes? Okay. So now the question is, what happens in the other quadrants, right?
We get negatives involved.
Yes. Okay, how are we doing so far? You guys are doing okay?
Yeah, great, I'm loving this.
I'm hoping I have helped you realize you don't just have to sit there and write this shit over and over and over again to memorize it. You do need to get to the point where if I just say, what's the cosine of 30 degrees on a test you can't use a calculator on, you should be able to just tell me. Yes? Yes. Are you good? You're stretching. Okay. All right. So. Let's talk about how to get into the other quadrants. Yes? So, I want to focus on something. If I look at like 30 degrees. Do you see how I got a little triangle here? Yes? So, can somebody tell me, remind me what this is in degrees, all the way over here. What's this? 180. So what is the angle That is 30 degrees back. That's kind of silly, yes? What's the angle that's 30 degrees back? 150. Those triangles, independent of how I've drawn them, they're supposed to be how related, those triangles. Do you guys understand? Those triangles, how they should be?
Inverse of each other?
How should they be related? Say again? More than that. Same thing. They're the same triangle. Do you guys see that? They have the same hypotenuse. Just one is over there. So how long should if sine 30 is 1/2, which is related to this guy's y side, yes? This guy has the exact same y side, doesn't he? Yes? So what should sine of 150 degrees be? Because do you see how 150, if I rotate, I end up with this triangle here? Yes? And that triangle is exactly the same as the triangle in the first quadrant. Okay, how are we doing so far? This is why you only have to memorize first quadrant values. So where are the negatives coming? Well, we're going to find out. So sine of 150 is equal to sine of 30 is equal to 1/2. By the way, 30 degrees, what is that in reference to? That 30 degrees is in reference to what axis? The x-axis. You with me? If I went this way, then that would have been reference to the y. So we call 30 degrees, we call that 30 degrees the reference angle, because we are creative people. You guys kind of with me?
Yeah.
Okay. If I know the reference angle, I know what value it's related to, because I have all the first quadrant values memorized. So if I know the reference angle is 30, that means is exactly the same as the triangle with 30 degrees in the first quadrant. But if I talk about the cosine, what's the cosine of 30 degrees? Root 3 over 2, because cosine loves the x-axis. 30 is not too far from it, so it should still be happy. It's not scared. Okay. Does anyone see why cosine of 150 has to be different?
Yeah, I still have a negative on
It's negative because x is
it.
negative back there, yes?
Sure.
Okay. Yes.
I'm still confused.
Are you cool with this stuff just sitting here?
A little bit.
A little bit. Okay, we got to start there. Because that's what builds to this, right? So, where did I... Here, we started with this guy. And that's where we built sine 60 and cosine 60. From this representation, yes? This is every possible equilateral triangle. We created a 30, 60, 90 triangle. Then we got these values. So now we just have to memorize those. That's what sine of 60 is. That's what cosine of 60 is, yes?
Would it help if you looked at it with the graph?
Yeah, I don't know, maybe. Yeah, if you look at it.
If you look at it like a graph, it makes sense.
Graph of, what do you mean?
I see what you mean.
Like a graph.
We're not ready for that.
Oh, sorry.
If you mean like a sine graph or cosine graph,
No.
if you mean the unit circle,
Yes.
Okay. I kind of feel bad for you guys because
feel like
I
you
think the
should have
unit
known.
circle sucks. The unit circle is dumb.
What?
That's
I know.
not how we learned it.
I love the unit
I
circle.
love the
I know
circle.
you.
Should've taught me.
It's kind of like it's kind of related to what is that syndrome you have when somebody kidnaps you? Stockholm. Yeah.
Stockholm syndrome?
Yes.
That's what we have with the
Yes.
unit circle?
It is. It is. It really is.
How?
Because it's all right.
This is so complicated to me.
Also, Stockholm syndrome is
Okay.
So here, guys. Here, I'll show you this. If this is better for some reason. Okay.
Yeah,
I know some of you guys memorized this.
There you go.
It just
I shaded
this is so much better. Yeah. This is so much. Look at that. This just
You see, on the outside it's showing the x and the y,
But why are they that? Does this tell you why they're that?
No.
Okay, beautiful. So
Wait, what? What'd you say?
this doesn't tell you why they are that.
But I know.
Why are they this? How does it relate to cosine and sine?
You know cosine is negative.
Yeah. Unless you learn SOHCAHTOA, in which case you don't know that. So. Some of you guys were taught the unit circle. You might have been given blank unit circles and to fill it in.
Mm-hmm.
I see no reason to do that,
Aw.
personally. Yeah, I see Maria's being shocked at this revelation. So I'm really sorry. If you're looking forward to that, I'm not going to do that shit. I hate that.
I was waiting for the handout.
Nope.
She loves the unit circle
Nope.
so much she has one
Nope.
calculated.
If you listen, guys. If you like the unit circle, you learned it that way, that makes sense.
Yes.
So there's no reason for me to go over it. I love it. I'd rather go over it in a way that makes more physical sense. I'm just silly that way. Now, one thing this picture does, for one thing, is it's actually a circle, and I couldn't draw a circle. But it's made by a computer, so I don't feel too bad. So this radius is 1. That's why we call it the unit circle. This side is literally 1/2 long, and this side is literally rad 3/2 long.
Yep.
Okay. I have no idea if this would help, Kelvin. Obviously, all right, I feel kind of bad that I don't like this that much, because I'm obviously not going to be able to teach this with the normal enthusiasm if I don't like it that much. I don't think this helps. This might help you feel like you're I don't know what it does for you, to be honest. I really don't, and I'm sorry.
What if I do it?
No.
I have the
Okay.
enthusiasm.
So listen. This, did you guys learn the unit circle? Did you learn this?
I couldn't do it.
No. Did you talk about this?
Yes.
Yes, I think so.
Okay. This is what's important. This is what establishes what these are.
Yeah, like how, yeah.
So if you look at 60 degrees, it's 1/2 comma rad 3/2. Who cares? I know that cosine of 60 is 1/2. I know that sine of 60 is rad 3/2. If you want me to put it into a point, I could, but it doesn't do anything for you. Okay. Now, Kelvin, you said you're cool with these.
Yes.
Okay. These you just have to commit to memory. The unit circle does nothing for you in terms of making it easier to memorize this. So you have to commit these to memory. What I'm trying to get people to understand is it's easier to commit to memory if you remember sine likes y. 60 is closer to the y-axis, so sine of 60 should be the bigger output. What outputs can there possibly be? 0, 1/2, rad 2/2, rad 3/2, 1. Plus or minus those, depending on what quadrant we're in. How we doing? Yes. Okay, let me stop for a minute. So, right at this moment, if I said, what's the sine of 30 degrees?
It's 1/2.
Yes. At this moment, that's all you have to be able to do. If I said, what's the cosine of 45 degrees? Root 2/2. It's got to be the one in the middle, because 45 is in the middle. Yes? Do you guys see that?
Yes.
Right now, that's where I need you to be. What I was just about to do was to extend this idea into other quadrants, and we haven't fully gone down that road yet. So, if you're able to tell me sine and cosine of any of these, you're right where you need to be. First quadrant, can you tell me the sine of 45 degrees is with the cosine of 60? Well, yes. Are you guys with me? And yes, sir.
So would the cosine of 30 degrees be root 3/2?
Totally. Cosine of 30?
So they just swap the closer it gets to the x-axis and the closer it gets to the y-axis.
Yes, because one shrinks at the same rate the other one grows. That's why they meet in the middle. Does that make sense? So if this one grows to 1/2 here, the other one grows to 1/2 here. Yes, beautiful. So it sounds like you're right where I need you to be. You just felt like you were lost because I was starting to get into some new stuff. Do you agree or not?
I think it was just a lot of words.
True, I do speak a lot. I'm trying to get us to a point where we can work on this. You're not going to believe this. I got a worksheet to work on.
Yes.
I know, something new.
Favorite.
Not yet. Sorry, Maria. I mentioned it, and we're not ready for it. All right. Everybody's like, "Good God, shut this guy up." Okay, we're almost there, kids. So let's do this again. If I'm at 60 degrees, what's the sine of 60 degrees? Sorry? Rad 3 over 2. Sine like y. 60 is close to y. Sine is the bigger option. Yes? Okay, good. So what about what angle is 60 degrees past this angle? Yeah, what's this angle?
240.
This is 180. This will be 240. You guys with me? You guys see that? You guys see that? If I go 180 and then I go 60 further, of course I'm at 240, right? So what's the reference angle? 60. Good, because it's in reference. The reason we call it reference is in reference to the x-axis. And do you see how those two triangles are the same triangle? Just one's been flipped.
Yep.
Yes? Well, flipped and flipped.
Yeah.
What's true about x and y in that third quadrant?
They're both negative.
They're both negative. So what's true about sine and cosine? They're both negative. They have the same values, and you memorize those. You just plug the negative in on when you need to. You can stop for a minute.
Okay.
All right. So if I ask you, what is the, you can do it, Jeff, cosine of 60 degrees, no, yeah, the cosine of 240, here's how I would do this. You would graph 240, you would figure out the reference angle, and then you would redo this. Is cosine positive or negative in the third quadrant? Negative, so negative. So this is equal to the negative of cosine of 60. These triangles are the same, except one is totally positive, the other one's totally negative. You guys see that? And it's negative just because it's going the other way. I'm not claiming I can make a triangle with a negative side. You with me? But on the x-axis, those values are freaking negative. It's just the way it is. So cosine of 240 has to have the same numerical answer as cosine of 60, but it also has to be the negative of that, because I'm in an area where x is negative. So what's cosine 60? Cosine likes x, 60 is nowhere near, so what's cosine 60? 1/2. So it's negative 1/2. That's what the cosine of 240 is. Check it in your calculator. My meds could have just run out. Any moment, that could happen, kids. Makes class very exciting. What meds are you taking, Jeff? So if you do cosine of 240, become a thing. No, don't become that thing.
It's -1. It's -1/2.
I don't know how to use my calculator. Yay, -1/2. Okay, good. You with me? So I need you to understand, going forward, some of the tests and quizzes are going to have a part 1, part 2. Part 1 you can't use a calculator for, and then you turn it in, you get part 2, and then you can use a calculator. Because I need to know you know how to do this shit without just plugging in the calculator. Aw, Jeff, what the shit? All right.
Why do you hate me, Jet? Why do you hate me?
Tomorrow?
No, it's not a test tomorrow. No, the quiz tomorrow is only 6667.
Oh.
Trig started at 7:01. Trig started at 7:01. Okay. How are we doing so far? Can somebody tell me, based on what we've done, what the secant of 240 is? Thinking too much? What's secant related to? It's the reciprocal function for sine. Cosine. S goes to C, C goes to S. You know what I mean when I say that? Sine goes to cosecant, cosine goes to secant. That's what got me through. If it's not good enough, you could go on your own memorization.
No, that's good.
Sometimes you get it right. Sometimes you're like, where's that unit circle? I'm not gonna let it. So what's secant of 240? You take cosine of 240 and you flip it. -2. Done. Notice, do you have a secant button in this dumb thing? Do you have a secant button?
Yeah, we do actually.
You get a second?
Do you?
I didn't want to use it.
No, you don't.
No, you do.
Is that in math? I mean, you look for it to be honest.
Inverse.
No. Oh no. Oh no. Oh, Damien.
I
Damien.
got excited, sorry.
You were not in the room where it happened. We already just talked about that. That is an inverse function, meaning it will take the output as an input and give the input as an output. It's not one of.
Yeah.
So you literally, if you want to check this in your calculator, you literally have to do 1 divided by cosine of 240 to get the secant. You with me? If you want to know the cotangent, you got to do 1 divided by tangent of
I
angle.
remember now.
You guys understand what's happening?
Yeah, I remember.
Okay.
Oh, yeah.
I know this is a lot, but the level of math we're doing is very minimal,
Yeah.
but there's a lot of memorization in the background. I understand. Okay. So what's true in the first quadrant? What's true about x and y?
Everything's positive.
They're both positive. So that means that everything that's dependent, like cosine and secant, are positive. Sine and cosecant are positive. Cotangent and tangent are positive. Yes? Everybody just loves that up there. What about the second quadrant? What's true about x and y? X is negative. Y is positive. So what's positive in the second quadrant? Sine is positive, which automatically means cosecant is positive. What else is positive? Anything?
That's it.
That's it. Cosine is negative, which means secant is negative. Sine and cosine have different SIGNs. You have to start freaking spelling these out. The sine and sine. Okay. Sigants, I like that. So the secant of sine and the secant of cosine.
I'm sorry.
Well, it's a little Miss Washing Machine here. She's not going to stop coming up with good shapes.
But not because
Yes.
my stuff sticks.
Okay, hold on.
Which one's are negative and which one's are positive?
Oh. So I just wrote down the only things that are positive. These are the only things that are positive in the second quadrant because they only depend on y.
Just sign it.
The hypotenuse, by the way, is always positive because it's just rotating. It's just always positive as it rotates. You guys with me?
So it's just sign and cosine?
Sine and cosine, so cosecant. Sine and cosecant are the only positive things in the two. Tangent and cotangent are positive divided by negative, so they're negative. Cosine and secant are based only on x, so they're negative. Is everybody with me? So everybody's happy there. I want somebody to knock back one time. Oh my God, I'm just taking forever. I just talked too much. I'm sorry. Down here, x and y are both negative.
Yeah.
So what's actually positive down there?
Tangent and
Good. Tangent and cotangent are positive down there, yes? Everybody else is negative. Is this making sense so far?
Yes, right.
Again, don't memorize this shit.
Oh.
Because I'm telling you, sine likes y, cosine likes x, you just think, what quadrant am I in, and what's the sign of those things in the quadrant? Then you can put it together.
Yep.
What about the fourth quadrant? X is positive, y is
Negative.
negative. So what's positive?
Cosine.
Cosine, good.
And
Secant,
secant. And that's it.
and that's it. Because again, cotangent and tangent are ratios of different secant things. Okay. It's like Monty Python was like, "Knights."
What?
They pronounce night that way.
Sure.
So don't memorize this. I did want to at least draw it out once for you.
Yes.
Right? So that's why you only have to memorize quadrant 1 values, because you're just rotating the triangle and changing certain things negative or positive. Okay. I think we're ready. We might be ready for me to shut up. You guys are like, yeah, 30 minutes ago. So let's see how much of this we could do. Oh yeah, that's true. I did sneak radians on this also,
Oh, that's good. Nah, it's all good. We got it.
but we'll see.
I
Okay,
got it. I got it. I got it. I got it. I got it.
we'll see.
I think maybe.
I'm excited. I might not actually. I'm excited. I know I've done it before, so I'm excited. But I don't think I've done it.
I got it. Jeff comes over.
Yeah, I mean, I got this. Something like go seek it and seek it.
All right. Oh.
I got it really fast.
Oh no.
In the interest of time, let's get into this. I think I need sleep. I think we got most of the first part of this better understood. Correct me if I'm wrong. But did the first one go pretty quickly? I mean, 30 is obviously closer to the X. And then 70 is closer to the Y. 50, Y. 45, both and neither. Or you can say same. Like, and then 270, it's on the y-axis, so it better be closer to the y-axis. Good. Okay. This is the stuff we have to memorize. When I try to do stuff that's not in the first quadrant, it's going to be the same numbers, just positive or negative, based on what x and y are in those quadrants. That's why I use sine likes y, cosine likes x, instead of SOHCAHTOA. Because SOHCAHTOA don't say shit about this. So, this is the part you got to memorize. Sine of 30, 1/2. Because 30 is closer to the x-axis, sine don't like that. It's going to be the smaller option. Cosine 30? Everything reverse of what I just said. Tangent 30 is, yeah, because how do you build it? Sine over cosine, yes? So it'll be 1/2. The halves cancel. 1 over rad 3. If I rationalize that, I get rad 3 over 3. Oh my God. Does everybody agree with me that rad 3 over 3 is smaller than rad 3?
Yes.
All right, this is one thing you can do to memorize tangent if you want to. Tangent is either, well, shit, we got some more to talk about tangent. Tangent 0, rad 3 over 3, 1, rad 3, 90 is interesting. What's tangent again? It's sine over cosine. What's cosine at 90 degrees? 0. Tangent has what on the bottom?
0.
So what's tangent at 90 degrees?
Undefined.
It's 1 over 0, undefined. Good. So one possible output for tangent is undefined. Which makes sense because it's a ratio of functions, one of which can sometimes be 0. Okay, you guys. So where's cotangent undefined? What's on its bottom?
Tangent.
Tangent.
True, but when you write in terms of cosine and sine,
Sine.
sine's on the bottom. So where's cotangent? Undefined. 0 degrees. Pi, or 180, sorry. Yes? You guys at all with me?
Yeah. Yeah.
I keep throwing more new stuff in there, but I'm sorry.
Yeah.
Cosine 60.
Like the hypotenuse. It's just like the measure.
Oh, I'm sorry. I never finished this. Tangent has sine on the top. So it is small when sine is small. Guys, tangent is small when sine is small. Tangent is big when sine is big. So tangent of 30 is small. Tangent of 60 would be rad 3. That's bigger than rad 3 divided by 3. I personally never memorized tangent until I started teaching. And then I did it enough, I'm like, it's stuck. And then I thought, let me figure out a reason. Oh, that's why. Okay, cool. So now I can tell you how to memorize it if you want to. Why do you not have to? Because you can build the damn thing when you need to. What's cosine of 60? Cosine likes x. And 60 is far from x, so it's 1/2. What's secant of 60? Nope. Secant of 60, not sine of 60.
Oh, 1 over half.
It's just 2.
which is 2.
Yeah, so 2.
And then sine of 45, because they didn't have a 45-degree angle yet. Right 2 over 2. And cosecant of 60 just to come out of nowhere or something. This is 1 over sine of 60, yes? So it's the flip of rad 3 over 2. So it's 2 over rad 3, which is 2 rad 3 over 3. Oh my God. Maybe?
What?
Tai Chi. This shit's done.
I can't wait for the English language to undergo another full revolution.
Oh yeah, that's happening all the time. Okay. My God. 150. So I was telling a few people, but basically a reference angle is how much I stop short of the x-axis or how much I go past the x-axis. It's always positive. How much did we stop short in this case? That's crazy. What's true about x and y at this angle? X is negative, y is the crazy. 315. I stop short by how much? All right, I'm sorry. We need a ghost hunter show because I just heard a ghost. That scared me. It's 45 degrees, so reference angles are always positive. One reason we want that to happen is so they reference the first quadrant, and that's where we have things memorized. What's true about x and y here? X is positive, y is negative. Negative 120, I go 90, and then 30 more. How much did I stop short of this? 60 degrees, because that would be negative 180 all the way across, right? And of course here, x is negative, and y is negative. Okay. 5 pi over 4. So here's the way to look at it without having to convert it to degrees. If I go a full pi, I haven't gone 5 pi over 4 yet. Do you guys see how much of a pi past a full pi? How much of a pi past a full pi is this? 1/4. So the reference angle is frickin' pi over 4 because you just told me it's 1/4 of a pi past, which is a tongue twister of a freaking sense. Okay. Do you guys see that? So we're going to have to slowly get more used to radians. I know I've been using degrees a lot just to introduce the ideas, but we have to introduce radians into it a little more. And of course, x and y are both negative, thank you. And then 11 pi over 6, same idea. What's 12 pi over 6? And where's 2 pi on the picture? 360. So if I go 11 pi over 6, I stopped how short? Pi over 6, that's the reference angle. X is positive, y is negative, just to cut to the chase. Now, notice what I did. I'm a very nice guy sometimes, every now and again, not a lot, sorry. Cosine of 150, we already discovered the reference angle. We know anything that goes like x is going to be negative, yes? So I rewrite this as negative what cosine 30 would have been. Because literally, physically, this triangle is the same as that triangle. So we've got this memorized. So I just have to put the value in, but I know it's going to be negative. So this is negative rad 3 over 2. Kick-ass, thank you. Does that make, do you see the work that goes into that? So on a quiz or a test, I'm going to say, find these, show reference angle work, blah, 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 blah. Okay, and I'll try to remember to write actually blah, 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 blah. So 315, we already did the work up here. So this is equal, what's true about tangent here, since these two have different SIGNs? What's true about tangents, SIGN? If there's different SIGNs, negative. So it's the negative tangent 45. 45 degree angles kick ass for tangent and cotangent, right? What's this negative? 1, because 45 is where sine and cosine are the same. Kick ass. 5 pi over 4 is this guy. Don't draw it again, Jeff, dear God. Y is negative here, so it'll be negative sine of pi over 4. Pi over 4 is what degrees? 45 degrees. What's sine of 45 degrees? Rad 2 over 2, done. This will be, what's true about Secant is 1 over cosine. Cosine here will be, no, cosine will be positive or negative? Positive. So this is 1 over positive cosine of pi over 6. Pi over 6 is 30 degrees. What's cosine of 30 degrees? Root 3 over 2. So once again, we get 1 over root 3 over 2, which eventually becomes 2 rad 3 over 3, like it did before.
Yes, indeed.
Okay, maybe.
Wait, you
Yes?
said pi over 6 is
30 degrees. Yeah, because pi is 180. Yeah.
Okay.
All right. I'm sorry I'm going a little fast, but we're basically out of time. This last one is nifty because you could be the guy at the tip of the shadow, and there's a little device you can use that will measure the angle to the top of something, while some other guy is laying down like this rolling tape measure you could do, walking towards you. So in the time it takes you both to do that, you can figure out how tall the tower is long before you would have freaking been able to climb to the top of the damn thing. Yes? So we do this with trees all the time. So this is 78.5 degrees. This is 90. You just put that little dude in a box. What else do we know? What's this? 104. And of course, this is what we want to know. I'm just going to call it H, no matter what you call it.
Just to confirm, it's not to scale, right?
It is. I don't care. I don't think it is. No. So then, yeah, this would obviously be way taller, but it's okay. Again, the triangle is leaning away from us. Okay. Don't know if anybody understands what I mean. What trig function relates that angle with those sides? Why would I not use sine or cosine? Do I know what the hypotenuse is?
No,
Do I care what the hypotenuse is?
not really.
Good. I wanted somebody to go, you might not, Jeff, but I, okay. So what trig function relates these sides? What trig function relates these sides? Tangent. Tangent of 78.5 degrees is equal to what? What ratio? How do I solve for h? Multiply. And then if you plug this in your calculator, who is it? 511? Yes. Was it feet? Yes. So that is literally something they do in surveying. So they use trigonometry to not have to do certain things. All right, I'm sorry, guys. That was one of the longer classes. I really packed that one full. I appreciate you dealing with me. Please don't forget your wallet. And I'll see you guys next time. If you have any questions, I can hang out for a few. If you have any concerns. Did I remember to turn this on? I did.